Why did the Titanic sink? A scientific investigation. Hello, dear viewers. Today we will tell you the scientific reasons behind the sinking of the Titanic and the details of this tragic event, one of the 20th century's most famous shipwrecks. The Titanic disaster was not just a shipwreck, but a tragedy in which many technological, environmental, and human factors came together. Let's explore the scientific reasons behind this event, Titanic's construction, and technological features. First of all, let's talk about how Titanic was built and the technological features it has. Titanic was built in 1912 by the White Star Line and was touted as the largest and most luxurious ship of the era. The ship was approximately 269 meters long, 28 meters wide, and 53 meters high. Weighing 46,000 tons, this massive structure was considered a marvel of modern engineering. Titanic's hull was equipped with 16 watertight compartments, each of which could be closed in case of flooding. Theoretically, it was thought that the ship would not sink even if 4 compartments took on water. However, the fact that the tops of these compartments were not completely sealed caused water to overflow from one compartment to another. This led to a faster sinking than expected. Iceberg collision. The most well-known cause of Titanic's sinking is the collision with an iceberg in the North Atlantic. On the night of April 14, 1912, the ship was traveling at about 22 knots per hour when lookouts spotted an iceberg. However, there was not enough time to maneuver due to the speed of the ship and the sudden discovery of the iceberg. The ship struck the iceberg on her starboard right side and tore her hull 90 meters below the waterline. Physical effects of collision. Following the impact with the iceberg, 5 watertight compartments on the right side of the ship were damaged and began taking on water. This caused the ship to sink faster than expected. The holes created by the collision caused the ship's watertight bulkheads to breach, and water quickly began to fill the ship. Scientists said the collision revealed the ship's structural weaknesses, in particular that the metal plates and rivets were not strong enough. Metallurgy and materials science. The quality of the steel plates and rivets used in the construction of the Titanic played an important role in the sinking of the ship. Research in the 1990s showed that the steel used on the Titanic contained high levels of sulfur, making it brittle at low temperatures. It was also found that the iron used in the rivets was of poor quality and broke easily during a collision. Steel and sulfur content. When the content of the steel plates used in Titanic was analyzed, it was found that they contained high amounts of sulfur and therefore became brittle at low temperatures. Sulfur adversely affects the structural integrity of steel and causes it to become brittle at low temperatures. In the cold waters of the Atlantic Ocean, this caused the steel to crack easily in the event of a collision. Quality of rivets. The quality of the iron used in Titanic's rivets was another factor that increased the severity of the accident. Research has revealed that the iron used in the rivets was of poor quality and broke easily during the collision. This caused the steel plates in the ship's hull to dislodge and more water to fill the ship. Human factors. It is a fact that human error played an important role in the sinking of Titanic. The fact that the lookouts did not have binoculars in their hands when they noticed the iceberg, the Captain Edward Smith's decision to continue sailing without slowing down, and the radio operators ignoring the iceberg warnings from other ships all contributed to the tragedy. In addition, the lack of sufficient number of lifeboats on board and the lack of coordination in rescue operations also contributed to the increase in casualties. Lack of equipment for lookouts. The spotters did not have binoculars when they spotted the iceberg. This prevented them from spotting the iceberg earlier, and they did not have enough time to maneuver. The binoculars are known to have been in lockers, and the key was lost, demonstrating the role of human error in the tragedy. Captain's decisions. Captain Edward Smith decided to continue without slowing down despite the iceberg warnings. This decision caused the ship to be at high speed at the time of the collision and reduced the chances of maneuvering. In addition, the captain and crew did not take the iceberg warnings seriously enough and did not take the necessary precautions. Shortcomings in rescue operations. The lack of sufficient number of lifeboats on Titanic and the lack of coordination in rescue operations also contributed to the increase in casualties. There were a total of 20 lifeboats on board, and they were capable of carrying less than half of the total number of passengers and crew on board. In addition, as the ship sank, many lifeboats were launched before they were full. Conclusion and lessons. The Titanic disaster led to many lessons in shipbuilding and maritime safety. After this tragic event, maritime rules and safety measures were tightened. Today, ships are equipped with more sophisticated radar and sonar systems, and international maritime rules require a sufficient number of lifeboats. The sinking of the Titanic was not only a technological and engineering failure, but also a lesson in the limits of humanity in the face of nature. This event has once again demonstrated the importance of safety measures and crisis management. We have come to the end of our video and shared with you the scientific reasons behind the sinking of the Titanic and the lessons learned from this tragic event. We hope this video has helped you learn more about the Titanic. See you in our next video. Bye.